In this class, we will be studying about this phenomena called refraction. We have been studying about reflection, isn't it, by plane mirror as well as spherical mirror. So, actually when you look at a mirror, you see your reflection, no doubt about it. So, the rays that are coming out of your body, the light rays, they go and hit the mirror and are reflected back. The word is reflection, and we know the standard rules of reflection. Angle of incidence is equal to angle of reflection. They are all the three are in the same plane. All those things we know. Do you think any light can pass through that when you are looking at a mirror? And suppose I have a mirror right in front of me. A person is standing behind that mirror. Do you think that person can see me? The mirror is blocking the way, isn't it? Because light cannot pass through the mirror. It is just getting reflected because it is highly polished. Even perhaps this is also might be reflecting because it is quite polished. Okay. If you come very close to it, you can see your own reflection. Okay. So, reflection is possible when there is a surface which is highly polished, highly shining, so that you can see your face or whatever it is. The light cannot pass through it. So, you know that the objects, the medium through which the light cannot pass is known as opaque. So, we have a lot of opaque objects. Not all opaque objects can reflect. Suppose I am standing in front of a wall, I do not see my reflection also. Okay. So, that is also not reflecting. So, it is absorbing all the energy, all the light energies. Light travels in a straight line as a ray. So, when it falls on the medium, any medium, either it is reflected or rather some of the rays are reflected, some are absorbed as heat, because if I have a mirror and I have a huge amount of light constantly falling on that mirror, you can see that after some time the mirror also gets heated up, because light after all an energy, it gets converted into heat when it is on the mirror for a longer time. So, the light is absorbed as heat, it raises the temperature of that medium, the light is reflected, the light can also pass through that medium. So, the light rays which travel in a straight line through any medium, say air, we have studied that light travels in a straight line. When it falls onto any other medium, either it can be reflected or other something is reflected, some portion of the light is also absorbed, which is converted into heat, it heats up the medium. Depending upon the type of medium, the light can also pass through that. For example, the light does not pass through maybe a wall because it is opaque in nature, but through a transparent or translucent, which is like in between transparent and opaque, translucent, the light does pass through that. Particularly through transparent medium, the light will totally pass through the medium also, like water, you can say glass, there are various types of glasses. So, through all the light passes. So, let us take this as a glass slab. Okay, you have a normal here, maybe I can extend it a little, I hope it is a straight line, yes. Okay. So, now you have an ray of light falling on this point at the normal. So, we know very well this is angle of incidence. Naturally, some of the light ray will be reflected with the rule that I is equal to R, that is angle of reflection. Since this is the glass slab and this is air, some of the light rays will also pass through the glass slab because it is transparent in nature. So, it just passes, but what we have found that it does not follow the straight path as it was supposed to follow. Within a medium, within air, it always travels in a straight line. Within another medium, again it will travel in a straight line. But when the mediums are joined, or rather when they are meeting each other, at that point of contact, the ray of light suddenly changes its speed. Its speed gets changed. Since we know that in air the speed is maximum, in fact in vacuum it is maximum, the speed of the light is 3 into 10 power 8 meters per second in vacuum, but for air also we can take the same number because it is just mildly different. Okay. So, for air, for all practical purposes, we will be using the same value as 3 into 10 power 8 meter per second. Okay. Since that is the maximum value of the speed of the light, nothing can travel, or the speed of the light is not more than that at any other medium. So, obviously in all other mediums, whether it is passing through a glass slab, it is passing through water or maybe through some oil through which it can pass, then the speed reduces. So, the speed of the light in air, if it is 3 into 10 power 8 meter per second, in glass slab it is going to be less. So, due to this reduction of the speed of the light, what happens? This refracted ray, not reflected ray, refracted ray comes closer to the normal. So, there is a change in the speed of the light when light travels from one medium into another medium. This phenomena is refraction. So, just in one line definition, refraction is the phenomena which shows that the light changes its direction of motion, propagation, when it travels from one medium into the another medium, and due to which its speed changes, its direction of propagation also changes. So, what was supposed to be like this as a straight line suddenly has become like this. So, now you have this small angle between normal, this can be say taken as RF, because I do not want to confuse between this and that. In most of the diagrams this will not be there, because we will be talking only about refraction. Then you can here also you can mark it as R, as long as you specify very clearly that what that R means. It means refraction, angle of refraction. But if you want to show both reflection as well as refraction, it is better that we mark that with some other alphabet as RF, say refraction. Okay. So, this is angle of refraction, this is angle of incidence. From the diagram itself we are seeing that I is greater than R. So, whenever a ray of light travels from air into any medium, in all other mediums through which the light can travel, this angle of refraction will become less than angle of incidence. That is, the ray gets closer to the, it moves, bends closer to the normal, making this angle smaller, isn't it? If that is 60 degree, perhaps this is 30, I do not know, surely less than 60. So, angle of R is less than I in a set of medii where this is a rarer medium. Now, this is known as optically rarer medium, and this is known as optically, this density has nothing to do with the density we have studied as mass per unit volume, not that. Okay. So, this is optically denser medium. So, please do not confuse this density with that density. Okay. So, optically denser medium. So, whenever the ray of light passes through an optically rarer to an optically denser, from here to here, the angle of incidence is always more than angle of refraction. That means the ray bends towards the normal and its speed reduces. So, the speed of the light is less in an optically denser medium. The speed of light is maximum or higher in an optically rarer medium. We may not always have the same combination. Perhaps you have a glass and water or water and glass. So, between the two depends upon in which case the speed is less, accordingly the ray will bend. So, whenever the ray of light travels from optically rarer into optically denser medium, it bends towards the normal. But the phenomena of refraction as such says that there is a change in the speed of the light whenever the light travels from one medium into another medium. So, that is the definition of refraction. We will go into much detail of that. We will see whether this RF can sometime be more than I, all those things we will be seeing now.